Hi guys, welcome to today's lesson. So today we will be doing organic chemistry and we will be going over the summary table. Organic chemistry, it is a very important and a very interesting branch of chemistry, and it counts more marks like in terms of the exam, so ensure that you ace this chapter. You can score yourself really great marks. So we have our summary table here. So what are we going to do? The first thing that we're going to do is to go over some important definitions that you're supposed to know for exam purposes. So we are going to start by defining what a homologous series is. A homologous series, it is a group of atoms that contain the same functional group and they also have the same general formula. So we'll also define what is a functional group and also the general formula. Let me start by defining what is a general formula. The general formula, it is a formula that indicates the types of atoms and the ratio of the atoms to one another. And then the functional group, it is a group of atoms that determine the physical and chemical properties of carbon compounds. And then we have the suffix. Suffix is an end name. It is an end name. As you can see, A and E, that is a suffix for this particular homologous series. And then we have the example name here and also the structural formula. So the structural formula, it indicates which atoms are attached to which within a molecule. So it gives us more detail in terms of the compound that we are working with. And then we have the condensed structural formula. So the condensed structural formula, it is a formula that shows the way in which the atoms are bonded together in a molecule. And then the molecular formula, it indicates the type of atoms and the number of each atom in a molecule. So the first homologous series that we're going to be looking at, it is an alkane. Okay, so an alkane doesn't have double bonds between the carbon atoms. This is what makes it different from an alkene and an alkyne as well. So this is a general formula for an alkane. I really advise you guys to know the general formulas for all the homologous series. That will come in really handy when it comes to naming the organic compounds. So this is the functional group. I really advise you to know also the functional group and also the suffix. And then we have the example name, which is a propane. As you can see, the propane contains 3 carbon atoms, right, and 8 hydrogen atoms. So this is a condensed structural formula. So this condensed structural formula for this one, it doesn't contain double bonds, right? There's only single bonds, and this one is the molecular formula for an alkane. And an alkene contains, in its functional group, it contains a double bond between the 2 carbon atoms, and then it has a general formula of CN, H2N, and then the suffix, it is ENE. This is the name, right? Can you see the differences between the two, right, in terms of the suffix, right? So the suffix for this one, it is ENE to indicate that it is an alkene. This is a structural formula, the condensed structural formula, which has a double bond here to indicate that it falls under alkenes, and also the molecular formula. Then we have alkynes. Alkynes, they have triple bonds between the carbon atoms, as you can see in their functional group. And then their general formula, it is CnH2n minus 2. And then they have the suffix of YNE. The name is going to be propyne to indicate that it is an alkyne. And also they contain the triple bond between the adjacent carbon atoms. And then this is the condensed structural formula for propyne and also the molecular formula. And then we have haloalkanes or alkyl halides. Halo means that they contain halogen atoms, right? Halogen elements. So halogens, as you know, that it is fluorine, chlorine, bromine, and also iodine. So this X indicates that we have what, a halogen element. And then we have the suffix, which is ANE, to indicate that it is an alkane, but it has a halogen element. So this 2 indicates that the position of the bromine element. And then we have the structural formula here. The structural formula, there's Br here to indicate that it is part of a haloalkane. And then a condensed structural formula which has a bromine here. That means the bromine is attached to the carbon atom. And then here is the molecular formula with some bromine here. And then we have alcohols. Alcohols, in their general formula, they have OH to indicate that they fall under alcohols. Their functional group, it has OH. OH, it is attached to the carbon atom. And then we have the suffix which is OL, and then the name which is propan 2O. This 2 indicates the position of the functional group. This is the structural formula. And then we also have the condensed structural formula and also the molecular formula. Then we are going to move to aldehydes. Aldehydes, they have a suffix Al, and then this is their functional group. So it's a carbon attached to the double bond oxygen and also a hydrogen, right? So we will look at the differences between the general formula of an aldehyde and also the ketone, so that you guys cannot confuse the two. So here we have our propanol. This Al indicates that it is an aldehyde, right? And then this is a condensed structural formula, and then the molecular formula. I hope you guys can see the position of the oxygen, right? So this will help you to differentiate between an aldehyde and a ketone. An aldehyde has a double bond oxygen in the end of the chain, and then the ketone has a double bond oxygen in the middle of the chain, right? So the carbon atom, they have to start from 1 to 2 up until infinity. And then we have the ketones, which the carbon atom has to start from 3, 4, and so on. And as I told you guys, that the ketone has a different suffix from an aldehyde. The suffix of a ketone is ONE, and the example name is propanone, right? It has a double bond oxygen in the middle of the chain. And then we have the condensed structural formula. We have our oxygen in the middle here. I hope you guys can see the differences between the aldehyde and a ketone, but they have the same molecular formula, right? And then we are done with our alkyl halides, our alcohols, aldehydes, and also ketones. So right now we are going to look at some carboxylic acids. These are acids, right? So they have the general formula of CnH2nO2. Their carbon atoms start from 1, 2, and so on. So this is their functional group. I hope you guys can see the differences between the functional group of carboxylic acids and also ketones, right? It has a double bond oxygen and OH as well, right? And then we have the oic acid, that is the suffix, and this is the example name, which is propanoic acid. So this functional group here indicates that it is an acid, some type of an acid. And then this is a condensed structural formula, which is COOH. The other one, it is a double bond oxygen and OH. And then we have the molecular formula here. And then we have esters. Esters, they are so much interesting. They are very interesting. So this it is a functional group of esters and their general formula. And then they have a suffix of oate, and then this is the name, which is ethyl here, ethyl branch, and then methane, which makes it ethyl methanoate. And then this is a condensed structural formula for ethyl methanoate and also the molecular formula for ethyl methanoate. Thank you very much for joining us today. Please do like, comment, and subscribe. See you guys on my next video.